Ever wonder how AI agents learn to tackle new challenges without starting from scratch? Imagine a robot that's mastered opening a window. How does it quickly adapt to opening a drawer? Both involve pulling, but the mechanics differ. That's where meta-reinforcement learning comes in, but here's the twist. Real-world tasks often have sparse rewards, like learning a sport with only vague hints about what's working. Traditional methods struggle here. They try to rebuild reward signals from scratch, but when feedback is scarce, it's like solving a puzzle with half the pieces missing. That's where SimBelief steps in, a framework that helps AI spot hidden similarities between tasks, even in confusing environments. So how does it work? Think of tasks as puzzles. SimBelief doesn't just look at the final picture, it identifies shared patterns. For example, opening a window and a drawer both involve pulling, but the mechanics differ. By learning these common structures, the agent can adapt to new tasks faster, even if it's never seen them before. The key: a latent task belief metric. Imagine a hidden space where tasks are represented as points. The closer 2 points are, the more similar their underlying structure. SimBelief maps tasks into this space, measuring similarity based on their dynamics, rewards, and how they evolve over time. This lets the agent think, hey, this new task feels familiar, it's like the one I solved earlier but with a twist. Here's the magic. Instead of brute forcing through every possibility, the agent uses these similarities to jumpstart its learning. It's like having a cheat sheet for a test. You don't need to memorize everything, just recognize the patterns. The paper shows this works wonders in environments with sparse rewards, like the MuJoCo and PandaGym benchmarks. Why does this matter? Real-world AI needs to handle unpredictable situations. Whether it's a robot navigating a disaster zone or a self-driving car facing a rare scenario, generalizing from past experiences is crucial. SimBelief's approach isn't just a tweak, it's a leap toward more efficient, human-like learning in machines. So next time you see an AI adapting to something new, remember, it's not just guessing. It's spotting the hidden connections, the shared DNA of tasks, and using that to learn faster. Thanks for watching, stay curious and let me know your thoughts below. Imagine learning a new video game. At first it feels overwhelming, new rules, unfamiliar controls. But if you notice similarities between this game and ones you've played before, like enemy behavior or level structures, you adapt faster. That's the idea behind SimBelief, a new approach in AI that helps machines learn smarter, especially when rewards are scarce. Traditional methods struggle in complex environments. They get stuck because they can't quickly spot connections between tasks. But what if the AI could remember how tasks are similar? That's where the latent task belief metric comes in. Think of it like a shared language. This metric mathematically defines how tasks relate by analyzing their rewards, actions, and outcomes. It's not just about surface-level similarities, it's about understanding the structure of a task. For example, a robot learning to open a door can use this metric to recognize that a new door is just a variation of the old one, maybe with a different handle. Here's where it gets really clever. Researchers proved mathematically that this approach guarantees stable learning. It's like giving the AI a roadmap. If two tasks are similar, the system can transfer knowledge between them. And this works no matter how complicated the environment gets. This isn't just theory. They backed it up with a theorem that calculates the maximum error when transferring knowledge between tasks. The formula considers 3 factors: how rewards differ, how actions lead to changes, and how far apart the task representations are. The smaller these numbers, the smoother the learning. Now let's break down the algorithm. SimBelief acts like a multi-tool for AI. It starts by gathering experiences from multiple tasks, then builds a hidden map of how those tasks behave. Next, it compares these maps to find similarities, and finally, it tweaks its strategy based on what it learns. This approach outshines older techniques like Perl or MetaCURE, which focus on uncertainty or probabilities. While those are useful, SimBelief's mathematical rigor makes it better at handling sparse rewards. Experiments on benchmarks like MuJoCo and PandaGym demonstrate its effectiveness, showing faster adaptation and more robust performance. The future of AI isn't just about solving problems. It's about recognizing patterns, transferring knowledge, and learning smarter. SimBelief is a glimpse into that future. If you're fascinated by this, hit subscribe for more deep dives into cutting-edge AI research. Until next time, keep exploring,